Hello class, today we're going to talk about section 9.4, which is solving quadratics by completing the square. By the end of today's lesson, you will know what completing the square is and how to use it to solve quadratic equations. Recall from last chapter that we had a perfect square trinomial. That meant we could take the square root of the front, the square root of the back. We will double check and say 2 times the front times the back is equal to the middle, which indeed in this case it is. So our factor was x plus 5 squared when we broke down the factoring. So we're going to use this idea of perfect square trinomials to help us complete the square. We want to be able to break it down into this factor right here. So what we are going to need to do in order to do this is take the b value, so that x, that number in front of x, cut it in half, square that answer, and then add it on to x squared plus bx. This only happens when the leading coefficient is 1. So if it's not 1, we'll have to make it 1. So for example, I have x squared plus 6x plus c. This is what we're trying to figure out in order to complete the square. So my first step is to identify b, which in this case is 6. We're going to cut that in half, which is 3. And then we're going to square that, which is 9. That is what I'm going to add on to the end to give me a perfect square trinomial. So x squared plus 6x plus 9, meaning my factor is x plus 3 squared. So the completing the square part is this middle step right here. Go ahead and try this one on your own. Our answer here, -4 for halving it. Squaring it is 16, so that completing the square part is x squared minus 8x plus 16. We can use this concept of completing the square to help us solve quadratics, making sure that x squared plus bx are on one side of the equation and any numbers are on the opposite side of the equation. Going to go ahead and complete the square and then add that value to both the left and the right side of the equal sign. Factor, take the square root of both sides, and then solve for both values of x. So going through, first we want to make sure that x squared and bx are on the same side. They are, so step 1 is complete. Then I'm going to go ahead and complete the square. So 12, cutting that in half is 6, and then squaring that I end up with 36. I'm then going to add 36 to both sides of my equation, giving me x squared plus 12x plus 36 is equal to 36. I'm going to factor the left side using the perfect square trinomial. One way to look at this as a shortcut, this is always going to be that halved value is what is going to go in the parentheses with x. So x plus 6 squared is equal to 36. I'm going to take the square root of both sides, which is going to give me x plus 6. Remember, squared and square root cancel each other out. And then remember, there are 2 square roots of 36, either positive 6 or negative 6. So there's always going to be 2 cases if you have a number, the positive case and the negative case. The only time that won't happen is if that is 0, because 0 does not have a positive and a negative value. If it's any number other than 0, you're going to have these 2 cases. Then we're going to go ahead and solve both of those cases, subtracting 6 from both sides. Our first answer is x is equal to 0, and our second answer is x is equal to -12. So we have our 2 answers that would satisfy this quadratic equation. Go ahead and try this one on your own. Cutting 6 in half, you get 3. Squaring that is 9, adding 9 to both sides. Then taking the square root, setting it equal to +3 and -3, you get an answer of 0 and -6. With this example, we do not have x squared and x by themselves, so we are going to need to subtract 3 from both sides to start the problem. The only thing that can be on this side of the equation is x's, and all of the numbers have to be on the other side. Going to go ahead and take and complete my square, so half of -14 is -7. Squaring that is 49. So I'm going to add 49 to both sides of my equation and end up with x squared minus 14x plus 49 is equal to 54. Again, we're going to go ahead and factor this, breaking it down into x minus 7 squared is equal to 54. Square rooting both sides, I end up with x minus 7 is equal to 7.35, and x minus 7 is equal to negative 7.35. When you end up with decimals for the square roots, you're going to want to round to 2 decimal places. Be careful you are following rounding rules. 5 and above should be rounding up, 4 and below should be rounding down. We're going to finish out this problem by adding 7 to both sides of both equations. So giving me a first answer of x is equal to 14.35, and then adding 7 to the second equation, I end up with x is equal to negative 0.35. So I have my 2 answers for the quadratic. Go ahead and try this one on your own. First thing you should have done is subtracted 12 from both sides. That's going to give you equal to 7. You're going to take negative 6, cut it in half, which is negative 3, and square that and add it to both sides. So you end up with it equal to 16. Factor and then square root, you get x minus 3 is equal to 4, and x minus 3 is equal to negative 4, giving you answers of 7 and negative 1. Last type of situation you're going to see is when this x squared term is not by itself. We cannot solve using this technique if x squared is being multiplied with anything. So our first step here is going to be to divide by the a value. So 0.1 divided by 0.1 is just 1. So I've got x squared. 2.4 divided by 0.1 is 24x. 25 divided by 0.1 is 250. And 430 divided by 0.1 is 4,300. Again, I'm going to take my next step of getting x's by themselves. So I'm going to subtract 250 from both sides, which is going to give me x squared plus 24x is equal to 4,050. Then I'm going to go ahead and complete the square. So half of 24 is 12. Squaring that is 144. So I'm going to add 144 to both sides. And I end up with x squared plus 24x plus 144 is equal to 4,194. Then I'm going to go ahead and factor that. So breaking it down to that parentheses piece, I'm going to have x plus 12 squared is equal to 4,194. We're going to square root both sides and get x plus 12 is equal to 64.76. And x plus 12 is equal to negative 64.76. I'm going to go ahead and subtract 12 from both sides to finish out this problem. My first answer is going to be x is equal to 52.76, and my second answer is x is equal to negative 76.76. Go ahead and try this one on your own, remembering to divide first. Dividing by 3, you end up with x squared plus 2x minus 4 is equal to 0. Add 4 to both sides. Complete the square by cutting 2 in half, which gives you 1. Squaring that is 1, so adding 1 to both sides. Factoring and taking the square root, and then subtracting 1 to solve. Your 2 answers are 1.24 and negative 3.24. I'm going to go ahead and show one more example, which is the last sort of case that you are going to run into. Again, start by getting rid of that a value. So I'm going to end up with x squared minus 4x plus 9 is equal to 0. Subtracting 9 from both sides, I'm going to get x squared minus 4x is equal to negative 9. Completing the square, cutting negative 4 in half is negative 2. Squaring that is 4. So adding 4 to both sides, x squared minus 4x plus 4 is equal to negative 5. At this case, we can stop because our equal value is equal to a negative. You cannot take the square root of a negative number, so if after you complete the square, that equals to part is a negative, you can stop and say that there are no real solutions to this problem. You'll want to make sure you include the word real, because when we get into Algebra 2, there actually will be a way to take the square root of a negative number. But for now, we are going with no real solutions. If you have questions about this or anything else from the lesson, please let me know when you get to class.